Hi everybody, what we're going to talk about today are solubility rules, and this chart has actually been on the back of your periodic table all year, but we haven't really talked much about it, so we are going to introduce it today. It's a pretty useful resource, especially now that we're doing solutions, and we are going to talk about solubility graphs next, so it's really important to know what is dissolving and what doesn't dissolve. Okay, so basically, if something is soluble in water, that means it's going to dissolve very nicely. The water molecules are going to surround it, and it kind of becomes very nice and mixed with the solution. Okay, if something is insoluble in water, that means it will not dissolve in water and it will not become part of the solution. It's actually going to form what we call a precipitate. Okay, so this is a word you are going to hear a lot. A precipitate is an insoluble solid that does not dissolve. Okay, so how do you read this graph? Okay, well, notice here it says these are all soluble. Okay, but then you have exceptions. So pretty much all of these compounds here, acetate, ammonium, nitrate, cyanide. Okay. Okay, this is hypochlorite. All of these guys are always soluble, okay? And there are no exceptions to it being soluble. They will always dissolve in water, okay? Now, bromine, chlorine, iodine, and sulfate are also soluble, except when they are bound to these guys, okay? So, for example, silver bromide. Okay, now bromine is normally always soluble, but because silver is now bound to it, it now becomes insoluble. Okay, same thing with sulfate. Sulfate is almost always soluble unless it's bound to any one of these guys. Strontium, barium, lead, or mercury. If it's bound to any of four of these atoms, then it will be insoluble. Okay? Also, the same trend goes with the chlorine and the iodine. Okay? They are also insoluble when it comes to these more heavy metals. So, again, all of these are soluble, but these are the exceptions. Okay, so I'm just going to clear this out a little bit. Now, if something is insoluble, again, we talked about it, so we said it does not dissolve very nicely in water. It will probably clump up and sink to the bottom and form a precipitate. Okay, so remember, a precipitate is an insoluble solid. Okay, it does not dissolve in water. Okay, now here, all of these guys are insoluble. Carbonate, phosphate, chromate, dichromate, hydroxide, sulfide. Okay, all of these are insoluble except, okay, when they're bound to ammonium or any of the alkali metals. Okay, the alkali metals are very reactive, so it's very unlikely that they'll allow any kind of clumping or precipitate to form. They will mix very nicely in with their solution. So all of these are considered to be soluble if they're bound to the alkali metals or ammonium. Okay, so for example, hydroxide. Hydroxide is normally insoluble. But if it binds to calcium, for example, and forms calcium hydroxide, it is now soluble. Okay, so these are the solubility rules. Again, everything here is soluble, except when it's with these guys, then it becomes insoluble. Okay, and then everything here is insoluble unless it bounds to any one of these guys. Then it becomes soluble. Okay, so we are going to look at a few compounds together and determine whether it is soluble or insoluble. Okay, So let's look at these together. So the first one is good old sodium chloride, that's salt. So I'm going to find chloride on my chart. Chloride is right here. And it is always soluble unless it's with silver, lead, or mercury. So because sodium is not one of those metals, it is going to be soluble. Next one, barium sulfate. Sulfate's right here. Sulfate is always soluble unless it's with, look, barium. Okay, so because barium and sulfate are together, this is going to be insoluble. Remember, these are the exceptions. So this is soluble, this is insoluble. Okay, down here, these are insoluble. And then over here, these guys are going to be soluble. Okay, lithium acetate. Okay, well, the acetates are up here, and they are always soluble no matter what. Strontium sulfate. Okay, sulfate is down here, and here's strontium. Okay, so strontium makes it an exception, so that is going to be insoluble. Okay, so pretty much we're just looking at this chart here. This is a resource for you. It isn't something that you have to memorize. It is something that you just have to know how to read. Okay, sodium phosphate. Okay, well, phosphate's down here, and phosphate is insoluble. Okay, but because it's bound to sodium, sodium is an alkali metal. Remember, your alkali metals are sodium, potassium, rubidium, cesium. Okay, so you got to know your group 1 metals. And because sodium is a group 1 metal, it's going to be soluble. Okay, lead sulfide. Okay, so here's lead. Here's sulfide, and then lead is not listed here. So that means it's going to be insoluble. Okay, so sulfide is always insoluble unless it's with ammonium, the alkali metals, calcium, strontium, or barium. So because it's none of those are listed, then it is going to be insoluble. Okay, magnesium nitrate. Okay, nitrate's up here. Nitrate is always going to be soluble. Okay, carbonate. Carbonate is right here. Okay, let me just kind of clear this up. Okay, so here's carbonate, and it says it is, these are the exceptions. Well, barium is actually a group 2 metal. It's an alkaline earth metal, so this is still going to be insoluble. Okay, we're going to finish up the other side. So we're looking at copper 2 hydroxide now. Okay, so hydroxide, it looks like is insoluble unless it's bound to any of these guys. Copper is not one of them, so it's going to stay insoluble. Okay, also ammonium hydroxide. Look, ammonium is right here, so that is an exception. So hydroxide normally would be insoluble, but because it's now bound to the ammonium, it is now soluble. Okay. Beryllium chlorate. Okay, chlorate's right here. And it's always soluble. There are no exceptions, so that's going to be soluble. Okay. Potassium dichromate. Okay, well, dichromate is right here. It's on the insoluble category. Okay, and the exceptions are if it's with ammonium and an alkali metal. Okay, well, potassium is a group 1 alkali metal, so because potassium is an exception, that's going to be soluble. Okay, moving on. Okay, carbonate. Okay, carbonate is insoluble unless it's bound to a group 1 metal or ammonium. Okay, well, calcium is a group 2 metal. It's an alkaline metal, so this is going to stay insoluble. Okay, silver chloride. Okay, chlorine is always soluble unless it's with, look, silver. So because silver is an exception, though chlorine is normally soluble, now it's going to be insoluble. Okay, 2 more. Ammonium sulfide. Okay, here's sulfide. sulfide is always insoluble unless it's with, look, ammonium. So now it's actually going to be soluble. It's going to be the opposite. Okay? The last one is phosphate. Phosphate is insoluble unless it's with ammonium or an alkali metal. So because zinc is actually a transition metal, this is going to stay insoluble. Okay? So basically all I've done is just looked at this chart. I find the anion first. The anion is the one with the minus charge. And then I look at who it's bound to. If whatever it's bound to, if the cation that it's bound to makes it an exception, then that's going to change its solubility. Okay? Okay, so this is what you should have on your page right now. And basically the last question it asks is, soluble compounds are in what state of matter? Okay, well, you have to remember we have solid, liquid, and gas, right? But the second you dissolve something in water, it's not a liquid. We consider it an aqueous solution. Okay? So an aqueous solution means that it is water or some liquid solvent, okay, but you have a solute dissolved in a liquid solvent. Okay, so I hope this helps, and we are now going to go on to solubility graphs.